Hello, so we have a question here on trigonometric algebra, and this is actually my first video where someone actually submitted a question. So this was submitted by Laurie. So, hi Laurie. Okay, so let's solve this problem. -2 cosine squared x minus sine x plus 1 equals 0. So first we want to get rid of this square because that's kind of hard to work with in this case. So we know that the Pythagorean theorem, the Pythagorean identity, which is sine squared x plus cosine squared x is equal to 1. So since we know that, we can just isolate cosine squared x on one side, so we'll get cosine squared x 1 minus sine squared x. We can apply that to here, and we'll just input that as cosine squared x. So bracket 1 minus sine squared x minus sine x plus 1 equals 0. Okay, so let's distribute this -2. So -2 times 1 is -2. -2 multiplied by negative sine squared x is just a positive 2 sine squared x minus sine x plus 1 equals 0. And if we apply this -1, or if we collect like terms, 2 sine squared x minus sine x minus 1 equals 0. So right here, we have to somehow apply the zero product rule, so we're going to have to factor something here. So this might look a little bit confusing, but let's say that a is equal to sine x. So we could just say that 2a squared minus a minus 1 equals 0. Okay, now this is a little bit easier to factor. So let's look here. So our first term here. So there's only two things that can multiply to each other to get 2a squared, and that's 2a and a. And now we have a -1 and negative a. So if we put a -1 here, the positive 1 here, then we can see that, well, 1 times a is 1a, and 2a times -1 is -2a. That will result in -a, and then positive 1 times -1 is -1. So this is how we factor it. And now we can just input sine x again. So 2 sine x plus 1, then sine x minus 1 equals 0. So that's the first step of this whole thing. Okay, so now I'll just erase all of this. And I'll just write this up here. 2 sine x plus 1 and sine x minus 1. That's equal to 0. Okay. Okay, so we can apply the zero product rule. So therefore, 2 sine x plus 1 equals 0, or sine x minus 1 equals 0. Okay, so now we can simply minus 1 on both sides here, and divide by 2 on both sides. So minus a half, sine x equals minus a half. Then over here, sine x, we can add 1 on both sides. Sine x equals 1. Alright, so let's start with this. Sine x equals minus 1/2. So let's draw the unit circle here. We have to keep in mind the boundary conditions. So sine x equals minus a half. So we know sine x is the y coordinate on the unit circle. So we know that minus a half exists in this location here, this location right here. Okay, so I believe that this angle here, that angle here would be 7 pi over 6, and this angle here would be well, we're going to take 6, we're going to multiply by 2, minus 1, that's 11, so 11 pi over 6. Okay, there we go. So now we have to keep in mind that we can do a second rotation, because they said the boundary conditions was a maximum of 4 pi. So we can do another rotation on top of that. And as we know, so I just write down the solutions we have so far. 7 pi over 6, x equals 11 pi over 6. Okay. Now we can add one rotation, and we know a rotation is 2 pi, and 2 pi is equal to 12 pi over 12 pi over 6. So we can just add 12 pi over 6 to both of these. Some more answers here. So x can also equal, well, we can add 12 to this value here, and 12 plus 7 is 19. So 19 pi over 6, there we go. And over here, we add 12 to 11, and that will result in 23 pi over 6. Okay, so these are 4 solutions that we can get out of here. And since our minimum value that x can be is 0, we can't go clockwise because that would be the negative direction. Okay, so let's try for sine x equals 1. So let's draw the unit circle again. Okay, so we know that sine x, that's the y coordinate. So we have one angle right here. Okay, so that angle there is pi over 2. Okay, and then we can wrap around one more time like this. And that would be, we know the period is 2 pi, and that's equal to 4 pi over 2. We're going to add that. That's going to be 5 pi over 2. So our solutions, why did I write s? Okay, and then we have x, so we can just write that down here. X can also equal pi over 2, and x can also equal 5 pi over 2. So right, not there, that's not a solution. Right here are 6 solutions for what x can be to satisfy this equation within the boundary conditions. Thank you, and I hope this clarifies the question, Laurie.